Okay, so today's lesson is the second part of the problem solving lessons that we're going to be dealing with, and this is where we kind of step it up a little bit, where we're really thinking about the really difficult higher questions. We're still using all the same processes. We're still using the formula of a trapezium or the area or the we still need to go through everything we need to. However, the difference is we're doing it algebraically here. Okay, and this is where it gets a little bit trickier. So looking at this one here, now notice that this here is from January 2019, so it was it's not that long ago, okay? And it's in the higher question, it's towards the end of the higher question, okay? Now this here is where we get to those trickier questions. We're combining two things. We're combining area, and we're also combining things like quadratics and things like this. Now we're not asked to solve the quadratic here. We're only asked to form the equation, but that's what we need to do. Okay, so it tells us here that the area of trapezium is equal to 133, and it says show that this can be written in this format where we're trying to find A and B. So draw this trapezium down first of all. Draw that trapezium down. So the actual area that we need to do in this isn't that tricky. We're just finding out the area of a trapezium. Now we are going to have to work backwards. It's all about kind of rearranging with this. So let's first of all, in this question here, write down what the formula for the area of trapezium is. So the area of trapezium is good. A plus B divided by 2 times by the perpendicular height. We know that. Now, the only difference with this question, which makes it really tricky, is the fact that our A and B are algebraic terms now. So A is our top, which is going to be equal to x plus 5. B is the bottom, which is equal to 3x minus 2. And the perpendicular height, h, is equal to that 2x minus 3. So that's what makes it tricky. Now, very similar to when we were working backwards with area, we do exactly the same steps and we follow the same steps. We write down our formula, which we've done already. We then substitute in all our values. We then simplify, and then we rearrange. And then we would go on to solve, but we're not doing that with this one. We're just going to rearrange, okay? So the other thing it's worth writing down is what the area is, because I know that the area is equal to 133. So I need to sub in these 4 values. So my area is 133, so let's sub that in first. 133 is equal to A plus B, so that's going to be equal to, now A is that x plus 5, plus B, which is 3x minus 2, all divided by 2, times by H, which is equal to this, H, which is 2x minus 3. So that's our first part. So I've wrote down my formula and I've substituted everything in. The next stage that I need to do is I need to simplify. Now the first part I'm going to simplify is in this bracket first. There's got to be quite a few steps to simplify this. So if I simplify inside that bracket, I know it's going to be x plus 3x, which is 4x. So let's start writing this down. 133 is equal to 4x. 5 minus 2 is equal to plus 3 times by, I'm going to get rid of that times now, the 2x minus 3, but I'm still dividing this by 2. Now notice I'm doing all divided by 2 now, just to make it simpler. Now we're nearly there with this. We just need to rearrange it to make it in this format, this 8x plus ax plus b. That's the format we're trying to get it in. So yeah, that's exactly what the next stage is. The next stages would be to times by 2. So times both sides by 2. So 133 times by 2 is equal to 266, which is equal to, open bracket, 4x plus 3 times by 2x minus 3. Now, we know that when we're dealing with quadratics, we always want to make it equal to 0. And that's what they're asking for here, aren't they? They're asking it to be equal to 0. That's what that is, okay? So to do that, I need to expand this bracket, expand the bracket, and then take that 266 over. So let's first of all, let's just take this here. Let's move it down here, just so, what's that 2? Where's that 2 gone? Here we go. So let's just put this down here because we've still got quite a bit to do. There we go. I'm just going to put a line down here. I'm going to take this up to here. Okay, so I've got 266 is equal to 4x plus 3 times by 2x minus 3. So I need to expand that bracket. Now, the best way to expand the brackets is using the grid method. So 4x plus 3, 2x minus 3. So 2x times by 4x is 8x squared. 2x times by 3 is 6x. Should have made that a little bit bigger. Minus 3 times by the 4 is minus 12x. And minus 3 times positive 3 is minus 9. So when I write this out, remember that those two brackets are this. It's equal to 266 is equal to 8x squared plus 6x minus 12x minus 9. Now I'm getting there now. I've only got a couple of extra steps to do. And those extra steps are to first of all simplify inside here. So this is going to be 266 is equal to 8x squared. 6x minus 12x is minus 6x minus 9. And then the last little part, remember, you're trying to make this equal to 0. So at the moment, it's equal to 266. So I need to get rid of that 266 by subtracting 266 from both sides. So I end up there with 0 is equal to 8x squared minus 6x. 9 minus the 266 is equal to, what is that? I'm going to do it in my head, I'll get it wrong. Negative 9 take away 266 is equal to minus 275. So minus 275, and that there is that done. Okay, because now we notice it's in that format that they want it. So this part here, the 8x plus ax plus b is equal to 0. We can put the 0 on the other side if we wanted to. 8x squared minus 6x minus 275 is equal to 0. So in which case, if I was typing this in, or if I wanted to say what a and b is, so let's just make it really clear. This is the format that they wanted it in. This is now the format that I've got. So I know that So let's have a look at the next question then. We're just going to do one more, then we're going to have a go at some questions. So this is our next one. So this here says 3 identical small circles are drawn inside one large circle, as shown in the diagram. And the centre of the circles lie on the diameter of the larger circle. What fraction of the larger circle is shaded? What fraction of the larger circle is shaded? Now, the first thing you might think of this, and this is what everybody thinks, is that, well, there's no numbers on here. There's nothing on here. Okay? And that's right. They've given you the question without any numbers. Now, sometimes this happens in percentages, and they say what percentage is this or what percentage is shaded. They've asked for the fraction for this one. Now, there's 2 ways you can do it. You can either do it algebraically, okay, which will work, okay, or you can actually make up a value. And now I think with this one, it's easier to make up a value, because it doesn't matter what value you make up, because it will always be in proportion, okay? However, you can make up some values which make this easier. So the problem I've got here is if I say this is, let's say I'm going to make up the diameter here. If I say the diameter is 2, the problem with that is that my diameter of the smaller ones then is going to be 2 divided by 3, which is a nasty number, okay? So we've got to really think about what number you're going to use. Now, you can see here the best number to use. And then you might think to yourself, well, let me use 3 then. So if I use 3 for the diameter, which will give me a diameter of the smaller one of 1, well, then the problem you've got with that is that the radius of that smaller circle is 0.5, so you probably wouldn't use 3 either, okay? What I probably would suggest is you definitely use a multiple of 3. I'm going to use 6, because if you think about these smaller triangles here, now again, it doesn't matter which, it doesn't matter what number you use. You could use 9, you could use 12, you could use 1 if you wanted to, but I'm going to use 6 just because across that diameter there are 6 radius in each of those smaller circles. So I'm going to say, just make it really clear to the timer, let the larger diameter equal 6. Now, you don't have to put a unit on that because I'm just letting it equal to 6. So my larger diameter here is equal to D is equal to 6, which means that my smaller diameter here for these ones is going to be equal to 6 divided by 3. So my smaller diameter is equal to 6 divided by 3, which is going to be equal to 2. Okay? So, if I was trying to find the area of the shaded, which I am, okay, find the fraction of the larger circle that is shaded, okay, if I'm trying to find the area of that shaded, I need to do the area of the full circle, take away the area of those little circles. So let's do that first of all, okay? So the area of the larger circle is going to be equal to, now if my larger diameter is equal to 6, that means that my radius is equal to 3. And if my small diameter is 2, that means that my radius is equal to 1. Just be careful with that. So my larger area is going to be equal to pi times by 3 squared. Now I'm going to keep this in terms of pi, which is equal to 9 pi. Brilliant. So then if I want my smaller area, so the area of the smaller circle, that's going to be equal to pi times by 1 squared. So pi times by 1 squared, which is equal to just pi. So if I wanted to then find my shaded area, That's going to be equal to the area of the larger circle take away 3 times of the smaller circle. So the area of this, let's put larger circle, subtract 3 times the smaller circle. And that's going to be equal to what have I done there? Stop. Okay, so the silly Mr. Adams. So the area of the larger circle was equal to 9 pi. Take away 3 times the area of the smaller circle, which is just pi, so 3 pi. So the shaded is equal to 6 pi. Now again, they're not asking for the shaded area. They're asking for the fraction of the shaded compared to the larger. Okay, I'm just going to put this over here. Here we go. So that's the shaded area. And this is my larger area here. So that's my shaded area and that's my larger area. And they're asking for the fraction of the larger circle that is shaded. So it's the fraction of the larger circle to the shaded. Okay? So the fraction of the shaded over the larger circle, which is equal to my shaded, which is 6 pi, over my larger circle, which is 9 pi. 6 pi divided by 9 pi is going to be equal to 2 over 3. 3 marks for that. Comes up on the higher paper. It's tricky, that one. Check that answer. 2 over 3. Yeah, it is. Super.